moving on to problem number 4 now. So what's given to us is our function f of x, and this is known as a piecewise function because our function is defined in pieces, meaning over this x interval, only when x is greater than 0, it behaves like this, and only when x is less than 0 or x is less than or equal to 0, it behaves in this fashion. So it's what's called a piecewise function. And what we're going to do right now is we are going to evaluate these particular x values. So what happens at f of -4? Okay. Well, what you do is that you check to see for this value. Look at this value, -4. Does it fit in the first criteria or does it fit in the second criteria? Meaning, is -4 greater than 0 or is -4 less than or equal to 0? Well, obviously, it fits in the second one, so that means the way, when I do this, I'm going to plug this into the second one. So 2 times -4 plus 5. So -8 plus 5. So we get -3. And that's it. So if you got that wrong, you're probably thinking like, what? That's it? That's it? So you're right there. Okay. Now let's plug in 0. Well, this one also fits in the second one because x is less than or equal to 0. So 2 times 0 plus 5 is just 5. And that's it? No way. Yes way. Are you kidding me? No, I'm not kidding you. Are you serious? Yeah, I'm serious. Okay. That's it for that one. Come over here. Do f of 10. Well, now we're going to use the first one because 10 is greater than 0. So 2 minus 10 squared, which is 2 minus 100, which is a 2, oops, which is just what, -98. Okay. Move along now. Get to a little bit of crustiness. Not too bad, though. So f plus g of x is saying this is the same thing as saying f of x plus g of x. So all they're telling us is to take f of x and then just add it to g of x. And look, they tell us what f of x is, and they tell us what g of x is. So basically, we just take these two functions and then we're going to add them. Okay. Let me just erase that just in case it's kind of in the way there. You can see it. All right. So let's add f and g together. So f is just x squared plus 5. Okay. I mean, isn't that f? That's f. Plus, what's g of x? What's this? The square root of 1 minus x. That's it? No way. Yes way. There's nothing else that you can do. You can't combine anything else together. This is it. You can't combine x squared with x because this has a radical. So basically, when it has a radical, this is known as like one entity. It's on its own. It's all wrapped into one thing. So you can't add the same thing else unless you had another radical that had the same thing in the radical itself. So we're done there. This right here means f. Oops. Try that again there. All right, so right here, this means f of x minus g of x. So basically, we're just taking this exact same answer and putting a minus sign in the middle. So x squared plus 5 minus the square root of 1 minus x. And there's nothing else that you can do to simplify that. That is it. All right, let's look over here now at this next one here. Let me just draw this little line right here so it's distinct. So now this right here means f of x times g of x. That's what it means. So like when you write gf of x, it means g of x times f of x. Okay, so f of x times g of x. Let's see here. F of x is this guy, right? So I'm going to do it. So x squared plus 5. But then times that by the square root of 1 minus x. Okay? You may have to put the parentheses there, but so if you leave it that way, you would have missed a point out of 2 because you could actually simplify this more, meaning you could actually multiply this single entity by 5, and then you can multiply this by x squared. So really, this times x squared would have gave you x squared times radical 1 minus x, plus this times 5 is 5 radical 1 minus x. So that would have been our final answer right here. Okay, so you would have got half credit if you left it like this. Full credit, go all the way. Go all the way, yo. Now let's look over here. There. Go over here. This means f divided by g. So this means f of x divided by g of x. I have a feeling I'm going to run out of room right here. I'm going to have to erase this. Actually, I think I am. And let's see here. Okay, whatever. I'll just kind of do this in here. So let's do f of x divided by g of x. All right. So if we do this, f of x is just x squared. Let's do it down here. X squared plus 5, right? That's f of x. A g of x is the square root of 1 minus x. Okay, you did this. That's good start. That's 1 point. You missed a point if you left a radical in the denominator. And that's going back to Algebra 1 and Algebra 2. We need to remember that we never leave square roots in the denominator. And what we're going to do is that we'll do a thing called rationalize. And let me show you what that means there. And basically, rationalizing means that you multiply top and bottom by your denominator. So see, we have a denominator of square root of 1 minus x. So watch this. If I multiply by this, the square root of 1 minus x, you say, well, what's the purpose of doing that? The purpose of doing that is we will eliminate the radical in the denominator. The square root of 1 minus x times the square root of 1 minus x, that's just 1 minus x. It cancels each other out. And then up here, x squared plus 5 times this, that's the same thing that we got from last problem. So if you multiply this again times x squared and then this times 5, you would get this nice numerator right here. So the square root of x squared times the square root of 1 minus x plus 5 times the radical 1 minus x. And then it's supposed to be a 1 right here. Let me try to make that a little more visible there. So this should be 1 minus x. There you go. So this would be the final answer that I was looking for right here. Find the domain of f. If you find the domain of f right here, okay, this right here, if you were to graph it, it would look like this. Okay. And that means all real numbers. I mean, it goes forever to the left and forever to the right. So my domain, I'm going to write it like this. I'm going to say it's the set of all x numbers. Actually, I'm probably going to say it's the set of all x numbers. It's all of them. So really, we could just say all real numbers then. Domain of G, if you were to graph this guy right here, it would look something like this, starting at the point 1, and then it goes like this. Okay, so that means my domain is going to start, my x has to be less than or equal to 1, meaning you start at 1 and then it goes forever to the left right there. Okay, and let's do these compositions. F of g and g of f. So if I do f of g, okay, f of g means f of g. Okay, and I could put the x right there. So this means this, f of g of x. So that means I take my function f, there it is right here, and I do something squared plus 5. You see it right here? Here's my function f. It goes right here. Something squared plus 5. I'm going to replace the x, though, with g of x. And g of x is the square root of 1 minus x. If I square a square root, then I just get 1 minus x plus 5. So 1 plus 5, so that's 6 minus x. And so that would be the final answer there. Here, if we go the other way around, g of f of x, g of f of x, and that means I'm going to take my function g and go 1 minus something squared, right? I take my function g, write it right here, but I leave the x blank, and my function now f, if you look back up here, is x squared plus 5. So that's what I put right here, x squared plus 5. Okay. Let's see here, x squared plus what am I doing wrong here? Is there supposed to be a square right there? Or? Oh, that's why. Okay, so I did that wrong. This shouldn't have a square right here. There's no square. So if we simplify this now, that's the square root of 1 minus x squared minus 5 because I distribute, right? Distribute. So then we finally get, just combine 1 and negative 5, we get negative 4, and then minus x squared. And then that would be that final answer right there.